Okay, so we'll proceed in solving the tedious calculus problem. Okay, so solving tedious calculus problem, our aim is not to take example by example and solve it. So anyway, we will do it, but that is not the aim. Aim is how we solve a problem. Any problem, how we can go in depth of it and try to solve it. Because first problem, second problem, if someone cracks it, that how we are solving it, then it will be same way that we are going to proceed in other problems. Any technology, it has inherent nature. That nature we need to identify, and then we can crack it. That's it. Like if I have seen a lion, if I have suppose that I want to understand how to solve a lion. How to solve a lion means how to tackle a lion. For that, it is not required that line by line, Lion, lion. I'll go and capture 1,000 lion, and each line we will study, not required. One line only, if someone study in depth, then more or less he can understand the nature of the line. That is required. If someone tries to tackle snake, then snake by snake is not required. One snake only if someone takes it and understand the nature of the snake in depth, then he can crack any number of snakes. I'm not saying that go and solve a snake, but this is how it is. Okay, so what is inherent nature of calculus? This is what we are saying. And we are not going by the modern way of calculus. Delta x, delta y, delta z, where delta x tends to 0, delta y tends to 0, delta s tends to 0. If you find it, then expand it. I'll try one. Okay, like we are trying to calculate weight. So rather than going for flux density and net flux, I believe it would be difficult for anyone. But everything is same. If I have density function, then how I can calculate the weight? If I know a mass, if I know a mass and mass has different density at different point, what is the weight of the mass? Or if I know flux density, if there is any point through which we have electromagnetic liquid is passing out, if I know the density of the liquid that is coming out, it is also called divergence. And if I take a surface, closed surface, how much is the net volume of the liquid that is passing across? There are two things that we have seen in kind of density. When we talk about density and multiplication of density with the volume, this is what we are trying. If I have a density function and if I multiply it by volume, then it gives me net weight. If density is weight per meter cube, if I have a density and the density is per second, only per second, and if I have a volume, if I multiply it, it becomes meter cube per second. And meter p cube per second means I have a one point, and from this point, the liquid is gushing out from here at very high speed. There is a small point here, and through that point, liquid is gushing out from here. If I take a closed surface, then with closed surface, consider closed surface is a cube. Then from the surface of the cube, how much volume of the liquid that is coming out? If I give the divergence of that point, or it is also called flux density, per second, just the unit of flux density is per second, just per second. And if I multiply it by the net volume of the cube, at the center of the cube, liquid is gushing out. How much is the flux? So flux density is considered as consider the liquid is gushing out from it. There is a cube. Cube means there is a box. Box is a cube. There is a box. And from the box, liquid is oozing out. Someone can consider it, right? There is a box. There is a kind of kind of okay of consider there is a wooden box. There is a wooden box. Wooden box means it's a cuboid. And from the surface, if someone is seeing the box from outside, from the surface of the wooden box, from the surface of the wooden box, liquid is oozing out from all sides. How much volume of the liquid that is oozing out from the all side? Make sense? So that is that is meter cube per second. That much is the liquid that is oozing out. Okay. In that sense, inside the box there is a liquid source. That's why liquid is oozing out. Certainly there is a liquid source inside the box. What is the power of the liquid source? There is a one point in the box, center of the box, liquid is oozing out. And then what is the power? That is how much liquid is coming out of the box. Divide it by the volume of the box. That is the power of the liquid that is the power of the liquid source. Or if you know the power of the liquid source, you multiply it by the volume, you get the net volume of the liquid that is coming out of the box. So I believe it is completely understandable. Like this is a box, this is cylinder, but consider this is a cuboid. And from this box, from this surface, this surface, this surface, liquid is oozing out. Okay, how much liquid is oozing out? This is some meter cube per second. If you divide it by the volume of this box, it will give you the power, because if liquid is oozing out from it at the center of this, there is a source through which liquid is gushing, and then finally it is hitting the surface and it is coming out. If you know the how much is the volume of the liquid that is coming out, divide it by the volume of this shape, you get the net power of the point at which the liquid is coming out. That power is by second, just by second. Okay, because liquid that is gushing out is meter cube per second, divide it by the meter cube per second. If someone knows the flux density that is per second multiplied by the volume, then you will get to know what is the flux or how much liquid is coming. Vice versa. Flux density is net flux by volume. Net flux that is coming out meter cube per second is volume into flux density. Or if this is a cuboid and inside this cuboid, every point in the cuboid, the density of material is different. There is a density of material in the cuboid, everywhere it is different. Then what is the weight of the cuboid? If I know the density, if density is everywhere same, 3 kg per meter cube, that is the density of a cube. If cube is 10 meter cube, then what is the weight of the cube? Density into volume will give you the net amount. Or if there is a flux density, then flux density into the volume will give the net flux, whatever it is. The idea is to multiply density with the volume to get the whatever we want. Now the question arising is that I know a density function, and that I know a density function, and density function is x square plus y square plus z square. If density is constant, if there is a three dimension, if there is a 3D, if this is a 3D, and inside that, all over this, consider this is a solid, though it is not a solid, but consider it is a solid, and everywhere it is made of rubber, and rubber density is everywhere it is same and it is constant. That is a kind of 3 kg per meter cube. This is what example I will give: 3 kg per meter cube. What is the volume of this? Volume of this, consider this is 1.5 meter cube. Then 3 into 0.5, 1.5 kg is the weight of this. But what about density is not constant? This item is made of different kind of material. At one point, if this is centered at the origin, consider this is centered at the origin. This is x-axis, this is y-axis, this is z-axis. This is centered at the origin. If that is the scenario, then from origin, if I go in x-axis, y-axis, z-axis, or any point x, y, z, density is different. Means density is dependent upon x, y, z. X, y, z is also called volume component. Volume component. So density is dependent upon the volume, but whatever it is, the net weight is density into volume. So density is dependent upon volume. At every x, y, z, density is different. If that is the case, then what is the weight of this shape? That is the question. So density into volume is the net weight of the shape. Density is x square plus y square plus z square plus 3. This is the density. At the origin, density is 3. Okay, on x-axis at point 3, comma 0, comma 0, density is 9 plus 3. At any point 1, comma 1, comma 1, the density is 3 plus 3. Everywhere density is changing. If that is the scenario, then what is the weight of this this sphere? That is the question. But answer is same. Density into volume is the net weight. D into V, where D is dependent upon V. This is primitive calculus, actual calculus. Actual calculus works in only two things. Actual works only two things. And these two things can be related by multiplication or division. One thing is independent component and one thing is dependent component. That's it. That is the main calculus. One thing is independent component, one is dependent component. How you relate them? Either you multiply it or divide it. If dependent component and independent component they are multiplied with each other, then it is integral calculus. If dependent component is numerator and independent component is denominator in division, then it is differential calculus. So that's it. What you want? I want multiplication. Then you have to go with integral calculus. Integral calculus, when you multiply two items, dependent and independent, when you multiply dependent with independent, then it cannot be direct multiplication. You have to go by fundamental of area. Area also gives multiplication of two items. If they are independent to each other, then they will lead multiplication of two items will lead to area of a rectangle. One is width and one is height. Otherwise, area of the if they are dependent and independent, it will again a graph where it will not be rectangle, but multiplication will come from the area only. And that is where integral calculus comes into the picture, because integral calculus multiply two items where one is independent and one is dependent by making independent as x-axis and dependent as y-axis and drawing a graph and calculating the area. That is the way to calculate the actual multiplication. If it is a rectangle, then it is one special case of the area. But it can be, the shape can be many. That is integral. How to find multiplication of two items when one item is independent x-axis, one item is height, that is y-axis, and height is dependent upon x, and draw the graph and calculate the area through which you are calculating the multiplication. That is integral calculus. So density into volume can be written as density into d of v. This is the signature of integral calculus. If someone is writing d, density into d, small d, density is capital D into small dv. dv is called differential part of integration. Means we are multiplying density with the d of v. Means we are trying to get the multiplication through calculating the area, not direct multiplication. Okay, x into x, direct multiplication is x square. If I go with one is dependent and one is independent and drawing a graph, that will be a triangle, then actual multiplication is x square by 2, because we are calculating the multiplication through area. Then x into x will become x dx. Here density into dv. If you take modern calculus, then what they say is, take a small, if you are trying to calculate the density into volume, that is d into dv, then inside this, take a small cubical region, very small region. Width is delta x, width delta x, and this side length is delta y and height is delta z, tends to 0. Then volume of that shape is delta x, delta y, delta z. Now expand the x, y and z. Okay, that x will be minus a to a, y will be minus a to a, and z will be minus a to a. That is the sphere, right? Sphere means x is, this is x axis, This is y axis. This is z axis. X is minus a to a. Y is y is minus a to a, and z is minus a to a. Will it solve the problem? Okay. Density. Consider density is 1. If density is 1, the density into the volume will give that where we are trying to calculate the weight of this, that will give actual volume because density is 1. So 1 into dv is delta x, delta y, delta z, where delta x, delta y, delta z tends to 0. If I make it tends to 0, then I can say dx, dy, dz, where x is minus a to a, y is minus a to a, z is minus a to a, the way they are. And in that case, it becomes x, y, z. A to a means it becomes a to the power 3. Knowingly, unknowingly, we calculated the volume of a cuboid, not a sphere. If you go with primitive calculus, then we are calculating the weight of a item. If the density into dV, if density is 1, then knowingly, unknowingly, weight will be same as the volume. That is 1 into dV. dV. Now, volume, how we calculate the volume? dV means not infinitesimally small. dV means there is a volume component that is independent. It varies on its own. D we place there to differentiate with the normal multiplication. Otherwise, it becomes density into V. That is normal multiplication. Density into dV. Now it is multiplication through calculation of the area, where x-axis is volume and y-axis is density. Okay, density is 1, means always it is 1. Okay, just only 1 into dV. What about dV? dV is, if I see the volume, calculation of volume, then what are the independent components in V? V is one independent component, that is V. But V constitute three independent components, X, Y, Z. All three are independent to each other. X, Y, Z, all three are independent to each other, and they are orthogonal to each other. They are at 90 degrees to each other. If they are 90 degrees to each other, then abstract volume will be x into y into z. D of volume will break into d of x into y into z. Because if I take Cartesian coordinate, x-axis, y-axis and z-axis, they are perpendicular to each other. So abstract volume notation will be d of v will break into d of x into y into z. Okay, thank you very much. So it is d of x into y into z. Then can I write dx, dy, dz? You can write dx, dy, dz because x, y, z are orthogonal to each other. What about limit? Limit is volume, lower limit of the volume to higher limit of the volume. Okay, but volume consists of three orthogonal components x, y, z. If they are three are orthogonal to each other, I can break this single limit, that is v1 to v2, into x1 to x2, y1 to y2, z1 to z2. Okay, now z is minus a, because if I see z-axis, that is vertical, the lower limit is minus a and higher limit is plus a, but it is not true. Here is the catch. Okay, the catch is that how we are proceeding now. First, we started with 4 dimensions. If someone is watching very carefully, then this integration lies in 4 dimensions. What are your 4 dimensions? 4 dimension, the 4 dimension is density x, y, z, comma d. At x, y, z, at any volume x, y, z, what is d? It is 4 dimension question. Actually, it is. It is a 4 dimension, 4D question. If someone is not believing that, because you said you started with 2D, one is volume, one is density. Okay, all right. We started with 2D. Now the limit portion, I can break the volume, that is 1D. Volume is x-axis, right? And density is y-axis. Now volume, I am breaking into two parts. It makes sense. The volume, I am breaking into two parts. One is z axis and one is xy plane. It makes sense because at the end I have to specify x, y, z. One is z axis and one is xy plane. If I see the algebraic equation of a sphere, then x square plus y square plus z square equal to a square, that is the radius of a sphere. Z equal to square root of a square minus x square minus y square. If I take two dimension limit, one dimension is z axis, another dimension is xy plane. I broke volume into two parts. One is vertical z axis, one is xy plane. This z axis is actually dependent upon xy plane. If I go little bit in depth, because this is the algebraic equation is, the algebraic equation of the surface is x square plus y square plus z square equal to a square. A square. Boss, you can write in other way also. X equal to square root of a square minus y square minus z square. Since all three are actually independent of each other and they are combined in a new terminology, abstract terminology called volume V, then I can take anything. X equal to square root of a square minus y square minus z square. Y equal to square root of a square minus x square minus z square. Anything. Then if I take y equal to square root of a square minus x square minus z square, then I'll take y axis and xz plane. I'll break volume into y axis and xz plane because all three are independent to each other in that fashion because integration is dependent into d of independent. Now this independent component, if someone is giving me volume 1 to volume 2 as an integral, then all right, there is no problem. But I have to break it into x, y, z. How to break it? These are the miniature complexity. If someone understands it, he can crack any problem. So I'm breaking this volume v1 to v2 density into d of v. Now v is in the limit v1 to v2. This is the primary calculus. X-axis, y-axis, y dx. X is from x1 to x2. Similarly, volume is from v1 to v2. Now v1, v2, this is the volume. Now volume I'm breaking into z-axis and xy plane. Then z equal to square root of a square minus x square minus y square. If that is the case, then z is dependent upon xy plane. If that is the case, the lower limit of this expression z equal to square root of a square minus x square minus y square. Z square equal to a square minus x square minus y square. Z equal to plus square root of a square minus x square minus y square, comma minus square root of a square minus x square minus y square. Two are there. So the lower limit of z is minus square root of a square minus x square minus y square. Higher limit is square root of a square minus x square minus y square. It is not minus a to a. The way because we are breaking now volume into z axis and xy plane and they are dependent upon each other. If I break the dv volume, if I break, then inside that I find 3d. Okay, or if you say volume is single x-axis, then if I break it, then I break it again into two axes. One is xy plane, that is x-axis, and one is z. Full problem I dissociated into two axes. One is volume axis and one is density axis. Now this volume again I am breaking into two parts. One is independent component xy plane and dependent component is z. Now in that sense z is minus square root of a square minus x square minus y square and higher side is square root of a square minus x square minus y square minus z square. This side dv is dx dy dz, or if someone is not satisfied, dz into dxy plane. This much we broke it, right? Dz. It will be triple multiplication dz dx dy because they are orthogonal to each other axes. So d of volume will break into three axes x, y, z. But anyway, I am breaking into two now, z and xy plane. Okay, what about now? So now the integration is z is minus something to plus something. Two integration. Another integration is xy plane, lower xy plane to higher xy plane. And here it is dv is dz into dxy plane. Now let's break more. dxy plane, now x-axis and y-axis are again orthogonal to each other at 90 degree to each other. Then dxy plane I can break into dx dy. Then here we have two integration. One integration is z that I settle it down. What about xy plane integration? Now again I'll break it into x and y. If I try to break it to x and y, then we will see xy plane. We had z axis. The beginning, the biggest, at the beginning we had vertical was density and horizontal was xyz volume. Vertical was density and horizontal was xyz volume. Then one by one we are tackling. Then volume, xyz volume become vertical as z and horizontal as xy plane. Now we are breaking xy plane where horizontal is x and vertical is y. Okay, if I see xy plane, this is xy plane and this is centered at the origin. So xy plane will cut at the middle. Okay, then if it cuts, then it forms a circle. If someone sees xy plane, if I just talk about xy plane, z forget it. If I talk xy, if I make a cross section of xy plane and cut it, it forms a circle. The equation of the circle is x square plus y square equal to a square. A is radius of the sphere. Then that will be termed as y equal to square root of a square minus x square. But you said x and y are orthogonal to each other. Okay, you can take x equal to the square root of a square minus y square, whatever comes to the mind. I am taking y equal to square root of a square minus x square. So y is dependent upon x and it makes a x axis and y axis. We started with y-axis as density and x-axis as volume. Then volume broke into y-axis as z and x-axis is xy plane. Xy plane again broke as y-axis is y and x-axis is x. Now we cannot break more. So y square is a square minus x square. Y is square root of a square minus x square and minus square root of a square minus x square. So y will go minus square root of a square minus x square to square root of a square minus x square. X, now x is only independent component that left. Now x is minus a to a. So limit is x is minus a to a, y is minus square root of a square minus x square to square root of a square minus x square. Z is minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. Density function d of volume became dz dxy plane. Then it became dz dxy dy dx. Now the full integration is density into dz dy dx. If density is 1, then we are in phase to calculate the volume. Okay, then dz integration is z, then minus to plus, then it becomes 2 into square root of a square minus x square minus y square dy. Okay, if someone consider y as a square root of a square minus x square cos theta, that is y, then dy equal to square root of a square minus x square minus sine theta d theta. If someone substitute it here, then it becomes square root of a square minus x square sine theta, and dy becomes a square root of a square minus x square minus sine theta d theta. If someone settle it down, it becomes minus a square root of minus a square minus x square sine square theta d theta. Integration of sine square theta is theta by 2 minus sine 2 theta by 4. Okay, that is the integration. What about theta? Theta, y equal to square root of a square minus x square cos theta. So theta equal to cos inverse y by square root of a square minus x square. If y is one limit, if y is square root of a square minus x square, then cos inverse 1. That is cos inverse 1. Cos inverse 1 is 0. And then minus 1. Cos inverse minus 1 is pi. 0 to pi. Theta we have to set 0 to pi. Sine square theta 0 to 0. I'm sorry. Okay, minus pi to 0. is pi to 0. Then if someone substitute theta by 2 minus sine 2 theta by 4, pi to 0, first is 0, another is pi, sine pi gone, minus pi by 2. It will become minus pi by 2. Minus is already there, minus minus gone, 2 is there, 2 2 gone, pi. Pi, I believe the pi is the net result. Oh, okay. So what it was, a square minus x square sine square theta d theta, that resolves into pi by 2. 2 was already outside, 2 2 gone. Pi remained. Pi I can keep outside. Then square root of a square minus x square dx. Square root of a square minus x square dx. Now if I take x equal to x x equal to a cos theta again, then dx equal to a cos theta. Okay, the dx equal to a minus sine theta d theta. Then it becomes a sine theta, again a sine theta, and minus same thing a square. Okay, so it leads to a square, I'm sorry, x square root of a square minus x square dx. Okay, so I am taking that square root of a square minus x square root a square minus x square dx. There is no square root, I can go directly, I believe. A square minus x square dx, I can go directly. Then it becomes a to the power, a square will become a square x minus x to the power 3 by 3. Okay, and x is minus a to a. Then a, someone set it, it becomes a to the power 3 minus a to the power 3 by 3. Okay, minus a, it will double it. That's it. Whatever we are doing, it will double it. So 2 I can keep outside. 2 pi is there outside. Now it is a to the power 3 minus a to the power 3 minus a to the power 3 by 3. Okay, then it will become 2a to the power 3 by 3. 2a to the power 3 by 3. Then it becomes uh, 2 pi is outside. 4 pi a to the power 3 by 3. That is the volume. Volume of a sphere is 4 pi a to 4 by 3 pi a to the power 3. Okay, so this is something that miniature technology, how minutely we solved it. Anyway, so but the actual problem is the density function is not 1, but we calculated the volume through this. Density function is not 1. Density is x square plus y square plus z square plus 3. Now we are trying to calculate x square plus y square plus z square plus 3 dz dy dx, where z is x, y is x. This triple limit is there. We saw last time, and it is very difficult, not possible. We cannot do through Cartesian coordinate system. Then we decided to go by the spherical coordinate system. If we go by the spherical coordinate system, then altogether we have to find different technology. But again, it will be same thing. Density into d of volume is the density into d of volume is the net calculation. What is density? X square plus y square plus z square plus 3. What is d of volume? What is volume? Okay, if we go by for the volume, what is volume? But anyway, we understood this. Now d of volume. What are the three orthogonal components in a spherical coordinate system? A spherical coordinate system has three independent components. One is called theta. Okay, spherical coordinate system. If this is xy plane, then there will be, and then in a spherical coordinate system, there is, if it is centered at the origin, spherical coordinate system, it is centered at the origin. From origin, if I draw a line, that is the radius. Radius all around the sphere, radius is constant. Okay, means radius in the constant in the sense all where, if this has radius as r, then from center all along if I move, the radius will be r only. If I talk about this sphere, but radius can grow from or 0 to whatever that big sphere will be. That is one component. Second component is this radius is moving along the x-axis and then it makes theta angle. And radius is moving along y-axis, then it makes phi angle. This you read in the book. But personally, I never got satisfied with this fundamental. One is independent component is radius, one independent component is theta, and one independent component is phi. Just mug up, just remember it. But what is the terminology there? No one understand it. Okay, let's consider. Then people will say, consider there is a small volume. Small volume. One is this, one is that, and one is that, and multiply and then expand it. Consider this is the small volume. Consider this is the small volume. Now, if I ask anyone to find orthogonal components, then he will say one orthogonal component is x-axis, one orthogonal component is y-axis, one orthogonal component is z-axis. So, if you combine three, it becomes 3D. Any 3D shape you can address through x, y, z. Can you find another orthogonal component? I don't know. This is what I found. There can be another orthogonal component. What you said, x-axis, y-axis, and z-axis. This is de facto. This is the inherent nature of a cubical shape. It starts with a line, then it starts with the rectangle or a cube or a square. Then if you add z-axis, it makes a cuboid. It is an inherent nature of a cuboid to have x-axis, y-axis, z-axis. But if it is a sphere, then can you find three orthogonal? If it is a volume, then certainly there will be three orthogonal components. Three. If it is a square, if it is an area, then two orthogonal components will be there. If it is a single line, then one orthogonal component, one component will be there. So three. Can you find three orthogonal component here? Okay, let me try it. Okay, if I am seeing a cube, if I am seeing a cube, then I can see any surface of the cube. If I have a cube, then I can see any surface of the cube. Anything, you can start breaking it up. So let's take one side of the cube. If I take one side of the cube, then it is area. If it is area, then it is combination of two sides. Then one, if I take this side, then looks like this and this are two orthogonal components there. Let's take another side. Here, this and this are orthogonal components. Let's take another side. Then this and the same thing, what we did. Let's take this as orthogonal component, then this and this. If I combine all six part of it, then I land up in three orthogonal components. They are like, oh, there are three orthogonal components. Try same thing here. No one is stopping you trying it. Let's take this sphere surface the way we did. When it comes to surface, then it is two dimensional. If there is a surface like this, then what two orthogonal component you are getting here? One is the vertical arc. If I take a round shape, what two component you get if this is an area? One is the vertical arc. If you see very carefully, there is one line. Means this. If I take this shape, if I take this shape, this area, then one is the. I can see one arc is like this. This is a circle. If you minutely watch it, this is a. If I cut like this, then this is a circle. There is an arc like this. This is one side of your area. Consider this is the full area. Another side is there is another arc like this. If I combine this arc, horizontal arc, and if I combine this vertical arc, they are perpendicular to each other, if you don't mind. They are perpendicular to each other. This arc and vertical arc, they cut each other at 90 degrees. They are perpendicular to each other, and if they are perpendicular to each other, multiplying them will give you the surface area. Makes sense. But we are talking about volume. It is 3D. If it is 3D, then I can make this sphere shrink or grow. How it is growing? If this is a sphere and if it grows, again we have a vertical arc and horizontal arc. Certainly it is not growing in that direction. It is growing in another component that is called radius that I can draw from the center of it. A line that is called radius. But it should be, all three should be perpendicular. So if I take a surface, So we broke into three reasons. One reason is that it is growing like this. One reason is it is growing like this. One reason is it is growing like this. How I found whatever is visible to me, from there I entered. I entered through the surface, and then I took kind of how the surface is growing. Okay, because I have only one surface, not like a cube, I have six surfaces. And quickly I found three vertical axes. Here, how the surface is growing. Then I found another one. But all three are knowingly, unknowingly, all three are perpendicular to each other. If you take horizontal arc, then radius is perpendicular to it. If you take vertical arc, radius is again perpendicular to it. And anyway, these two are perpendicular to each other. All three are perpendicular to each other. Okay, eureka, eureka. Miss, we found it. So there are three orthogonal components. One is radius, one is horizontal arc, and one is vertical arc. If you combine all three, again it is a vertical component. What is the vertical arc? If this is the line, if this is the angle called phi, then vertical arc is radius into phi. That is the vertical arc. If this is consider there is any radius of the sphere. If this is the radius, it makes phi angle. That denotes the vertical arc. Then r phi, r phi is the vertical arc. Similarly, if I take this radius on xy plane, one is vertical arc side. Now this is horizontal arc. If I take this on xy plane and move angle theta, then this arc is r theta, r theta. So three component is r phi, and r theta. Makes sense? But this r through which I calculated the vertical arc, and this arc I calculated a horizontal arc, are not same. It should start from the same point. This is r, one component. This is r phi, another component. From here only I have to think about theta. Then this is r sine phi. Now it falls on xy plane. R sine phi theta. So the dV, density into dV, is the net weight. Density into dV. V is multiplication of these three. Then only it becomes volume in 3D shape. Then only it becomes volume. The dV I can write as d into r phi into r sine phi theta, where independent component are theta, phi, and r. Now I can denote all three. If I break it, I denote all three with the d. Now it becomes dr, r d phi, r sine phi d theta. Altogether, dv becomes r square sine phi dr d phi d theta. Makes sense? And then we have x square plus y square plus z square plus 3. X square plus y square plus z square is radius square. That is a sphere. I can write it as r square. R square plus 3. R square plus 3 bracket close. R square sine phi d phi dr d phi d theta. Here, volume 1 to volume 2, I have to break it into r, theta, and phi. Okay, so we will do in this can be assignment that how we can break the limit, that is from volume V1 to V2 into theta, phi, and r. So that we will do in the probably in the next video. So anyway, don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.